Hello everybody! In this video, I will show you how to visualize your data in the Satori software. Once you run the software, you will be prompted with the main window. Here you can click on the Settings button in the upper right-hand corner and select your GUI preferences. From the first tab called GUI, you can choose which panels to visualize in your main window. I have selected 2D and 3D view for this video, and we can see them here on the side. And then you can also change the default mode from dark to bright. This might be useful if you want to export your figures for publications. Please note that any change made thus far will be applied only after you have quit and reopened the software. Each tab can be dragged and dropped to modify the software as feels more comfortable for you, like so. And they can also be expanded. To keep the formatting, you can, in Settings, check the Show Same Panes as in Previous Session box. You can also change the background image of the main window and of the time series. The document view will modify the exported images according to these settings. By selecting Show Icons with Text, as I have here, the software will assign a label to each icon, and here's what it looks like without. I will keep the box checked for the purposes of this video to make it easier to follow along with. Lastly, we have the option to show the deoxyhemoglobin time series with a dashed line. This can help to visualize both oxy and deoxy time series at the same time. Selecting the second tab labeled Data, we can choose whether to visualize the power spectrum for each condition and a normalized frequency spectrum. Moreover, we can select the channel length at which the software should recognize the channels as short. By selecting the interpolation method, you will choose which technique will be applied to correct for motion artifacts when manually identified in the full data plot. If your channels present saturation or corruption, the time series could contain NaN, which stands for not a number, or INF, which stands for infinite values. By clicking this option, we take care that these values are corrected. To load our data, we can click on the Open button, and the montage will automatically be loaded. I will load some sample data for us to use today. The Satori software supports the most common data formats for NIRx and the SRI files, which are proprietary files from Satori. Looking at the central panel, the big windows represent the long channels and the smaller windows represent the short channels. In each window, the ERA, event-related average, will be visualized, and you can double-click on the window to make it float, like so. And then you can drag it back into the top. This is the same for the 2D and 3D views. You can double-click, and you can put it back. The red dot is the source in the 2D view, and the green dot is a detector. If we select one channel, as we have done, the time course will automatically be loaded, and we can see in the red the oxyhemoglobin and in blue the deoxyhemoglobin. If you do not see the deoxyhemoglobin, as we do not right now, you can click on the corresponding box on the right-hand side, right here. And now you can see it. Now, going over to the frequency spectrum panel, right here, and we can expand it a little bit. The different frequency bands highlighted are a guideline for where the most important frequencies for the NIRx signal should be, namely the heartbeat, the respiration, and the task information from left to right. To zoom in, you can left-click and select the area you are interested in, like so. We can go ahead and zoom in even more. To zoom out, you can right-click twice, and the image will go back to its default scale. The ERA, event-related average, is automatically loaded if the experimental paradigm, right here, if the experimental paradigm is saved with the data. Here we can see the mean and the standard deviation for both of the tasks performed during the experiment. I'll expand it so it's easier to see. By clicking on the legend, we can, for instance, remove one task from the plot. I'll go ahead and remove all the standard deviations so that you can see this. Your data can also be visualized through the SNRIF file, SNRF file. This is particularly useful if you have auxiliary data such as motion sensors or some physiological measurements. By clicking on the Show SNRF down here at the bottom right, we can look into the information saved in the SNRF file, within which we can find the auxiliary time series. After clicking on one of the aux options, we can select the time series and click on Plot Data. This time series can also be saved as CSV or SDM to be used as a regressor for the GLM. More information about this will be presented in the dedicated video. Thank you for your attention.